Hello, Algebra 2. This is an extra help video for the Desmos activity. This is for Desmos slide number 2. Okay, so really quickly, this is a review from some old notes. So how many x-intercepts are there? And remember, x-intercepts, are where the red dots are at. So those are x-intercepts, so there's 3. And what about those x-intercepts? Well, if the graph goes through, the black line goes through, those are called single roots. But if the graph comes down, touches, and bounces back up, that's called a double root. And what you need to know for a double root is that a double root, where the graph comes down and touches and goes back up, it has an exponent of 2. So you'll see x squared. Okay, a single root where it goes right through the graph, then it's just parentheses, something like x minus 3 over here. Okay, but a double root, you need to know that the graph bounces on the x-axis and it has an exponent of 2 when that happens. Okay, so I wanted to go over how to find the degree and the x-intercepts of a polynomial from the function. So how do we find the degree? How do we find the x-intercepts? And then we're also going to talk about leading coefficients. So let's talk about leading coefficients first, because those are easiest. So the leading coefficient is the number that leads. So this would be a positive leading coefficient, and it's at 2/3, right? So positive leading coefficient, we could put a plus sign there, is 2/3. Where's the leading coefficient for this? It's positive at 7. Positive 7. And the leading coefficient right here on this one is a hidden -1. So this is a negative leading coefficient at -1. Okay? So that's your leading coefficient. That tells you if your graph arrows up or arrows down. All right, so now as far as degrees go, let me just erase this. I'm going to change this to black. There we go. Okay, so as far as degrees go, degree means how many x's in the problem. So you can see in between here, this is multiply. X plus 4 times x minus 1 times x plus 7. It's multiply, right? When you have parentheses together, it means to multiply. So what is this x times this x times this x? What's x times x times x? It's x to the 3rd. So this is 3rd degree. So you count your x's. X times x times x. That would be x to the 3rd. I'm just going to write that off to the side, so I have a little bit of room. So this is 3rd degree. Okay, so the next thing we need to do is to find the x-intercepts. So you take each item and we solve them by setting them equal to 0. So you just take each of these parenthesis items and you solve them by setting them equal to 0. And that's easy because if you're going to just go ahead and solve this, you would subtract 4 to both sides. So this would say x equals -4. Do you see how it's the opposite of that number? This one you would add 1 to both sides. So x would equal 1. You can see how it's the opposite of that -1. And then x plus 7, you would subtract 7. So that would be x equals -7. And that's the opposite of that +7. So kids know that shortcut. They just take the opposite. There are some problems where you have to do a little more work for that, but mostly kids know. So the x-intercepts, there's 3 specifically at -4, at 1, and at negative 7. So on the graph, you would have had dots at negative 4, 1, and way out here at negative 7, right? So that's where those x-intercepts are at. Negative 7, negative 4, and positive 1. Okay? That's what it means on the graph, right? Okay, so to answer this question is, how many x-intercepts? It had 3. What degree is it? X to the third. Okay, so let's do the next set. So what degree is this? Count the x's. So x times x times x times x. So this would be x to the fourth. So this is a fourth degree. Because there's 4 x's, right? So x times x times x times x equals fourth degree. And then now we just got to find out how many intercepts there are. And then watch this because this is a little different. So remember what you do is you take each item at the x's and you solve them. You set them equal to 0, right? So x plus 2 equals 0. So this front one's just going to say x equals 0. The front one's done, right? So here's one at 0. This one, if you move over the 2, you would subtract it to both sides. So x would be negative 2. Here's the next one. This one you would have to add 5 to both sides. So x would equal 5. Here's the next one. So we have this one. Negative 2, 5. This one, you would move the 3 over. So negative 3. And the last one. So we have 4 x-intercepts. 0, negative 2, 5, and negative 3. So there are 4 x-intercepts, specifically 0, negative 2, 5, and negative 3. If I were to draw that really quick on a graph, that would be 1, whoops, 1 minute, that's right, 0, negative 2, 5, and negative 3. Right? So that's where they would be on the graph, visually speaking. Okay, let's do the last one. All right, what degree is it? So here we have x to the third times this x, the front one, times the next x, times the next x. So how much is x to the third times x times x times x? X to the third, x to the fourth, x to the fifth, x to the sixth. So this is a sixth degree. This would equal x to the sixth. Okay. So you have x to the third, another one, fourth, fifth, and sixth. And then where are the x-intercepts and how many are there? This one counts for 0. This one counts, remember, it's just the opposite. Like this one right here, negative 2. See how it's just the opposite of that positive 2? So this one would be at negative 9. This one would be at positive 2. And this one would be at negative 3. So there's 4 x-intercepts. One at 0, negative 9, 2, and negative 3. Okay, so when you see this plane x cubed, you count it at 0. When you see a plane x, you count it at 0. When there is not an x out front, then you just ignore the 2/3 because that's just the leading coefficient. Okay? All right, now we're going to talk about the Desmos. So first I'm going to show you how I set up the slide. So if you can listen for just a minute. So on the side here, this one, this one, this one, this one, and this one all have positive leading coefficients. And if you look at these two, there's negative leading coefficient. So that's how I set these up. Right? See, it has the negative in front, negative. These all have positive in front. So that's how I set mine up. Doesn't matter which order, except some are the positives and some are the negatives. And then as for the cards, I put degree 2, degree 3, degree 3, and then I put degree 4, degree 4, degree 4, and then degree 6. So I just kind of set my cards up by the way the degree is. Okay, now for the degree 5, mine are already done here. I want to show you degree 5. So you can, so I'll come back to this video in just a minute. But let me show you degree 5 answers because there was a little bit different vocabulary on there. And so students were getting these wrong. So there's 2 cards with degree 5. They both have 3 x-intercepts. But this one says the x-intercepts are tangent. So these are the correct answers. What it means to be tangent just means a double root. That means it has an exponent of 2. That's what a double root means. I went over that at the beginning of this video. A double root means you have an exponent of 2. And you can see that happens twice. So there's 2 intercepts that are tangent, which means 2 double roots. So please go ahead on your Desmos right now. Make sure that you have these 2 cards set up properly. These are the right answers. So hook these 2 cards together and hook these 2 cards together. And then you can, I'll go back and help you with starting the other set. So hit pause here for a minute, okay? So that you can keep this on your screen. Hit pause. Okay, so let's just make sure that we can figure out the best way to do this. So hopefully your cards are all organized, somewhat like this. And if you could find the card that has, let's see, let's do a degree 3. So this card says the function has a degree 3. That means you have 3 x's. So which cards have 3 x's? This one does. And this one does. Because you're counting your x's, right? Then it says the function has a positive leading coefficient. Well, there's only one with a positive leading coefficient of 3. The other one has a negative. See the negative down there? It's a negative leading coefficient. And our card says that we need to have a positive. So these 2 cards are going to go together just based on that. Does it have 3 x-intercepts? Yes, it does. One at 0, one at -1, and one at +1. Because remember, you take the opposites. So these 2 go together. This one and this one match up. So it has a degree of 3. There's 3 x's. X is x to the 3rd. Has a positive leading coefficient of 3. And it has 3 x-intercepts. One at x is 0 for that front x. 0, -1, and 1. Okay? So now I need you to go ahead and match up the rest of these cards. And there's going to be one more video for slide number 3 on Google Classroom if you still need help with that. Thank you.